Hey, welcome guys. This video we're going to focus on the constant rate of change, and it comes directly from TEAC 7.4a. So for our first example, we're going to find the constant rate of change from a graph. And if you notice, if you start from the farthest left point of this line and you follow along, you notice that it's going up. I tell you that so you can remember that this is positive. Okay, so constant rate of change is just the change in y over the change in x. How's y affected by x? So x is your horizontal axis, y is your vertical. And remember, in 6th grade, you learned that x was your independent value and y was your dependent value. So the points are already labeled for us, and it's any 2 points you want from a graph. So typically on STAAR, you're not going to have the points labeled. So if it's the change in y, that's my vertical change. So from the left point, farthest left point, because when you read left to right. So you want to remember that. You'll go up 1, 2, 3, 4, 5. So my change in y was 5. Now, my change in x is 1, 2, 3, 4. So if you get in the habit of writing change in y over change in x, you really can't mess this up. Now it is positive, it's going up. If the question asks where it crossed the y-axis, well, you see it crosses at 0, 4, but that's for further along. All right, let's go to a table, which a table is points from a graph. So time is your hours, which is x in your independent value, because you control the time of maybe how many hours you work. And then your earnings is based off your time. So I have a preference on having vertical tables. So I'm just going to go 2, 4, 6, 7. Here's my x values. Here's my y. And don't forget, it's always change in y over change in x. Okay, so I'm going to start with my change in y. How far is 90 to 180? Plus 90. How far is 180 to 270? Well, that would be 90 again. Okay. And then from 270 to 315, it's not plus 90, it's actually 45. Now I'm going to do the same process on the left side. I always like to start with the right so you don't get confused. And so you have 90, 90, and 45. Now we're going to find my change in x. So the first change in x from 2 to 4, it's add 2. How does 4 become 6? Add 2. How does 6 become 7? Plus 1. So for my first ratio of change in y over change in x is 90 over 2. The second one is 90 over 2. And then the last one is 45 over 1. Well, 45 over 1, you're done. Now we're going to look at the others. Half of 90 is 45. And half of 90 again is still 45. So my rate of change is 45 over 1 or just 45. And so you'll see it in the slope-intercept form. So this would be your rate of change. And in this case, this is constant. And so that means it's just proportional. All right, let's go to our word problem. Sophia has a job putting thank you notes in envelopes to be mailed. In 2 hours, she put 42 thank you notes in envelopes. Write an equation that best represents y, the total number of thank you notes Sophia puts in envelopes, in x hours if she continues at this rate. So what you're doing is you're finding rate. So I really suggest creating your table, x and y. So I got 2 hours to 42 thank you notes. So I need to know 1 is. So I'm going to put a 1 right above 2 and then go, well, how did 2 become 1? Well, you divided it by 2 because it's half. We don't add or subtract. We multiply or divide. So since I divided 2 by 2 to get 1, which is half, now I need to know what's half of 42, which is 21. So at the rate that Sophia is going, it would be y equals 21x. So every time you plug in 21 and you times it by your x value, which is your input, you will get your y. And in this case, 21 times 1 is 21. 21 times 2 is 42. So we're done. That's a proportional relationship. There's nothing after x. I hope this helped. Thanks for watching.